Hello viewers, in today's class we are going to discuss one important problem from integrals, right? And in this class we'll solve this important integral with the help of the concept of beta gamma functions, right? So here our integral is 1 to infinity and the integrand is 1 over x raised to 5 times square root of x minus 1, right? So let us start and let us first take this integral as I, and here we'll make use of the method of substitution for integration, right? So here let us substitute x is equal to 1 over t, right? So this is the most appropriate substitution here, and here we see that the value of x varies from 1 to infinity, right? So the lower limit is 1 and the upper limit is infinity, right? So when we take this substitution x is equal to 1 over t, it implies that when x is 1, that is, we can also write this expression as t is equal to 1 over x, right? So when x is 1, t is equal to 1 over 1, that is 1. And when x is infinity, or we can also take this x is equal to infinity as when x tends to infinity, then t tends to 0, right? Because here we have 1 over infinity, right? 1 over a very big number or a large number. So 1 over large number, it tends to 0, right? So now x is equal to 1 over t. So the derivative of x with respect to t is d by dt of t raised to minus 1, because here we have 1 over t. So 1 over t can be written as t raised to minus 1. So this is minus t raised to minus 2. That is minus 1 over t square, right? So dx can be written as minus dt. Taking dt to this side, we have minus dt over t square, right? So now this integral I can be written as when x is 1, we have t is equal to 1. When x is infinite, then t is 0. And dx is minus dt over t square. And x raised to 5 is 1 over t raised to 5. And here we have square root of 1 over t minus 1, right? So now let us simplify this, right? So here we have a negative sign, so we can neutralize this negative sign by interchanging the limits. So we have 0 to 1. Here we have 1 over t square, and then we can take 1 over t raised to 5. That is t raised to 5 to the numerator. We have t raised to 5 over 1, and here we have dt, and then we have square root of 1 over t minus 1, which can be written as square root of 1 minus t over square root of t, right? Okay, so now here we have neutralized this negative sign by interchanging the limits, because we know that this property of definite integrals, that is a to b f of x dx, is equal to negative of b to a f of x dx, right? So if we interchange the limits in definite integrals, then the integral takes a negative sign, right? So now this expression, it goes like this. Here t square get cancelled, so here we are left with t cube, and we have 0 to 1 t cube. Square root of t can be taken to the numerator. We have t raised to half. Square root of t can be written as t raised to half, and then square root of 1 minus t can be written as 1 minus t raised to half, and here we have dt, right? So now we can write 0 to 1. Here the bases are same, so 3 and half get added. So we have t raised to 7 over 2, right? And here we have 1 minus t raised to half, and here we have dt. So viewers, now this integral can be written as I that is 0 to 1, and here we have t raised to 7 over 2 and 1 minus t raised to minus half, right? So we can take this term to the numerator. Now see, our aim is to convert this integral into the beta function, right? And beta function is also known as Euler's integral of first kind, right? So the beta function is defined as beta mn, and we have 0 to 1 x raised to m minus 1, and here we have 1 minus x raised to n minus 1 dx, right? So now see, here we have 7 over 2. So we can write this integral as 0 to 1 t raised to 7 by 2. 7 by 2 can be written as 9 over 2 minus 1, right? So 7 over 2 can be written as 9 by 2 minus 1. And here we have 1 minus t and minus half, which can be written as half minus 1, right? And here we have dt. So now we can see that this integral is similar to this one, except the variable. Here we have the variable x, here we have the variable t, right? Okay, so now we have m is equal to 9 by 2 and n is equal to half, right? This is n, this is m. So I is equal to beta of 9 by 2 and half, right? And here again we'll make use of an important relation connecting the beta function with gamma function, because we know that beta of mn is equal to gamma of m, gamma of n divided by gamma of m plus n, right? So here we have gamma of 9 by 2, gamma of half. Here we have gamma of 9 by 2 plus half, right? So now here also we can make use of one important relation from gamma function. See, gamma of n plus 1 can be written as n times gamma of n, right? So here we have gamma of 9 by 2, right? So gamma of 9 by 2 can be written as 7 by 2 plus 1, right? So if we compare 7 by 2 plus 1 with this one, n is 7 by 2. So we have 7 by 2 times gamma of 7 by 2, right? And repeated application of this result, this formula gives us 7 by 2. Here we have gamma of 5 by 2 plus 1, because 7 by 2 can be written as 5 by 2 plus 1. So we have 7 by 2 times 5 by 2 times gamma of 5 by 2. Again, this is 7 by 2, 5 by 2, and we can write gamma of 3 by 2 plus 1, and we can write 7 by 2 times 5 by 2 times 3 by 2 times gamma of 3 by 2, and we can now write 7 by 2, 5 by 2, 3 by 2, and here we have half times gamma of half, right? Because 3 by 2 can be written as half plus 1. And now in the denominator we have gamma of 9 by 2 plus half, that is equal to gamma of 5, right? 9 plus 1, 10, 10 over 2 is 5, right? And gamma 5 is equal to 4 factorial, right? So 4 factorial is 4 times 3 times 2 times 1, that is 4 3s are 12, 2s are 24, right? Okay, so now here we can write this expression as gamma of 9 by 2 can be replaced by this expression. So we have 7 by 2, we have 5 by 2, then we have 3 by 2 half, and gamma of half, right? And here also we have gamma of half, right? And in the denominator we have 24. So now see, this is 7 5s are 35, 35 times 3, then here we have 2 to the 4, to the 8, to the 16. So we have 16 times 24, and we know that gamma of half is equal to square root of pi, right? So now here we have square root of pi, and again we have here square root of pi, right? So this is 3 8s are 24. This is 35. Square root of pi times square root of pi is pi. And this is 16 8s are 128, right? So viewers, the value of this integral is equal to 35 pi over 128.